wanted to take a moment to clarify how base numbering systems are used in Arduino. Now, because of our walk through the microchip literature while using the PIC micros, there's especially one area that's potentially open to confusion. Now, in case you've forgotten, the base is the number of digits or options we can have in our numbering system. Binary is a base 2 system. It's either a 0 or a 1. There are only 2 options. Now, I didn't really get into octal, as you almost never use it, and I will certainly never use it in any of my courses, but it is out there. And as you probably guessed, octal is like octopus for 8. It's a base 8, so the digit could be 0 through 7. Decimal, the numbering system we use day to day, of course, is base 10. You have 10 options, 0 through 9. Hexadecimal is base 16. You have 16 different options, 0 through 9 and A through F. Now, in Arduino, unless you specify otherwise, you may have noticed that when we've been entering and using numbers, it's always been in straight decimal. This is the default for the Arduino compiler. If you don't specify the base numbering system you're using, it assumes your number is in decimal. But we'll use binary and hexadecimal a lot, so how do you indicate the numbers you are using are in binary or hex? After all, 1011, 0001 could be either a binary or a decimal number, or a hexadecimal number. So to indicate the base of the number we're delivering, we put a prefix onto that number. So let's say I wanted to send binary number 10110001 to an address. I would write it in the code with a B prefix, just like we did in microchip assembler. Now, hexadecimal can be confusing. The prefix to indicate a hexadecimal number is 0x. If you recall from the data sheets for the PIC microprocessors, we often ran into specific bits and registers which weren't used. So it didn't matter what you put in them. So we would often see binary numbers like 0x001100, for example. This can lead to confusion in Arduino and a lot of programming languages where 0x is actually the prefix used to indicate a hexadecimal number. So if I wanted to send hexadecimal 3F to a register, I would indicate it was a hex number with the prefix 0x. So I could declare a variable as integer my number equals 0x3f. My number would now be a hexadecimal value or a hexadecimal number of 3f. We'll see that 0x prefix a lot now, so heads up on that. I'll mention base 8 or octal in passing, even though I'll never use it, and you probably won't either. Nevertheless, its prefix is simply a 0. Now, obviously, if I'm sending a decimal number, it's either going to be 0 or else the number will not start with 0. For example, I'm not going to write the decimal number 23 as 023. I will simply write it as 23. So if that 0 is in front, it would actually be an octal number. Remembering that octal only has 8 digits. You're only allowed to have numbers 0 through 7. So if I typed in 028 or 029, for example, it's expecting an octal number, and you'd get an error because the numbers 8 and 9 are not allowed in octal, and you indicated this was an octal number by tagging it with a 0 on the front of the number. So there you have it. That's your numbering syntax for all of the bases.